Alright, so 1.5, okay, you should have taken notes. If you took your notes, you would know that this section is going to be dealing with what? Word problems. Alright, but for today's stuff, because we don't have a ton of time, you won't have homework tonight on it, okay, or classwork. There probably won't be time for you to even start it. So tomorrow when we do the word problems, you'll do everything in regards to that in class, hopefully, and if not, it'll be due Friday. And you're looking at a test next week on Wednesday. So, anyways, okay. So, 1.5 examples. Using the formula D is equal to RT for distance traveled to solve for the missing variable. This is on page 37 if you need the page number. Number 4, D is equal to 300 miles. R is equal to, we don't know, that's what we want to solve for. And T is equal to 4 hours. Alright, so these ones, pretty simple. You just set them up. And it tells us the formula is D is equal to RT. So the first thing you want to do is you want to actually solve the formula for the variable you're looking for. So we need R, so we want to get R by itself. So how would I get R by itself? Divide by T. I'm going to move the R to the left just so it's easier. So R is equal to D over T. And now then I can plug my stuff in. So I plug in 300 miles over T is 4 hours, which then is what? 75 miles per hour is the answer for that one. Okay, and you have to have units, so make sure you don't forget those. Yes. Yes, but you're still doing the same thing, are you not? No. Solve for the formula first. Or solve for the variable that you want first, and then do that. Because you're going to end up, I'm trying to get you prepared for, yes, these ones are easy, but there are some that are harder, and you need to be able to solve it first, and then plug the stuff in. The next set, same type of thing, but it's using the perimeter formula for a rectangle to solve for the missing variable. So something like 10, P is equal to 25 centimeters, W is equal to 5 centimeters, and L is equal to, that's what we don't know, we want to find out. So the perimeter formula is P is equal to 2L plus 2W. If you happen to forget, they do give you the formulas in the instructions. I want to solve for L, so how do I do that? Subtract 2W, so P minus 2W is equal to 2L. Now I divide by 2. Okay, I'm going to put the L back on the other side just so it's easier. P minus 2W over 2. Now what? Plug in P and W, so 25 minus 2 times 5 over 2. It gives me what? 15 over 2. Okay, in this case, because these are actually solving out like word problems, you can give me a decimal for these ones. Okay, so 7.5, and our units are centimeters for these ones. Okay, so these type, because they're word problems and stuff like that, you can give me decimal answers, okay, because you're actually getting like some kind of units on it. The reason I say leave the other ones as fractions is honestly your fraction should have been able to help you plug it back in and solve it easier. And also, that way everybody's is the same and uniform with improper fractions. But with these ones, especially something like this, that's pretty easy to figure out the decimal. Okay. Do we need to see another one of this type, or do we feel okay about this type? Yes. Number we'll go back. That one still gives you the same variable to solve for. We'll go back and do number 6. D is equal to 250 miles. R is equal to 50 miles per hour. And T is equal to, that's the one we're solving for. So we have D is equal to RT. This time I need to solve for T, so how do I get T by itself? Divide by R, so T is equal to D over R. And now I just plug stuff in. 250 miles over 50 miles per hour. Now, it looks like you're going to end up with like miles times miles over hours, but remember this is technically a fraction here, so when you flip it, your units are going to cancel to leave you with the hours you're looking for your T. You don't actually have to show that. I'm just explaining where that's coming from. So, what is this? So this is 5 hours. Alright, so the next type, it's going to sound a little bit confusing, but I promise it's actually probably the it's probably the easiest type that you do of these problems, but we'll see. 12, so you have a table that has X and Y values in it. Yep, so this one is the one for finding patterns. Okay, so we want to look at how we get from here to here, how we get from here to here, and here to here. Okay, so what are we doing every single time we move from one down to the next one? Subtracting 15. Okay, so that's what's happening every single time. Okay, so what we do is we set this up as y is equal to, you set it up with your initial value, okay, whatever your initial is, in this case it's 60. Then we say subtract 15. But how do we get from 60 down to 15? What did we have to do? How many times did we have to subtract 15? We had to subtract it 3 times, okay, but I need this to be a general formula. So I'm just going to call that X, and X is going to be this number up here. Okay, so if I were to plug in 3 for my X value, okay, 60 minus 15 times 3, that'd be 60 minus 45, which would give me 15. Okay, and that probably sounds confusing, but does that kind of start to make sense? If you were to plug in 1, okay, then you'd have 60 minus 15 times 1, or 60 minus 15, which would give you 45, and that gives you this value here. So if I ask you this, yes, this is the answer. Yeah, this is the answer right here. Okay, so I could give you a table and I could say, tell me what the value for y is when x is equal to 5. Okay, and you could fill that in. That's not what these problems are doing, but that is something you could do, and that's why this is useful. Yes? Yeah, so every time that you move down, because you're looking for a pattern in your table, so the 15 comes from, we started with 60, that's your initial value, which is why that's there, and then you subtract 15 to get to 45, you subtract 15 again to get to 30, and you keep going, so we could just keep going, and you'd end up eventually with negative values. But then, because we want to know how far out we're going, that's why we put the X on it. Because the negative 15 determines how many times it's changed to give us our final Y value. Okay. All right, let's look at another one. Um, 14, so we still have an XY table. Okay, and inside here we have 57, 107, 157, 207. Yep, so we're adding 50 every time. Yep, so then we start with our initial value. Okay, so y is equal to 57. Okay, just so you know, your book is going to flip the way they write these ones because it's adding them. But just always write the initial value first. It's the easiest way to remember it. So start with your initial value, and then every time we're adding 50. And we can do that as many times as we want, so that's why we're going to put an X on it. Okay? And then you could go back and check to make sure your formula is correct. I'm not requiring you to check it, but if you're unsure if your formula is correct, go back and plug in something like 1. So y is equal to 57 plus 50 times 1. So that's 50 plus 57, which is 107. And that's the value, so then I know that my formula works and is correct. Does that make sense? Okay. Do you feel like you need to see another one? Nope, we're good. Okay. I'm trying to decide if we have time to look at this next one. Let's go ahead and set up the next one, like draw it up and everything, and then we'll probably actually have to do it tomorrow because I don't think we'll get through it. Alright, so the next one is using a diagram. So you have basically, we're just going to call it a wall. Okay, with, we'll call it picture frames on it. My picture is not perfect, but we're just going to roll with it. Alright, so then the given information, we know that this wall is 15 feet. It tells us that each of these picture frames are 2 feet. And we want to know the space between. So all these values in here that go from picture frame to picture frame and to the edge of the wall. And we want them to all be equal, so that's why they're set up all to be equal to X. I think we can actually go ahead and get through this one. So this one, it's actually really, really simple. All you have to do is read the information across. X plus 2 plus X plus 2 plus X plus 2 plus X. So I've taken care X2, 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 X is equal to this 15. And then you just need to combine like terms for it. So I end up with, what's that, 4x plus 6 is equal to 15. Okay, so that's the equation set up for that one. These ones say to write the equation and solve for x. So how would I solve for x to actually see what that distance is? Minus 6, so 9. And then divide by 4, so x is equal to 9 over 4, which is 2.25, and we want to put our units back on it. Sorry, that marker is dying. It ends up being 2.25 feet between each of our pictures. Okay, so these ones actually are probably the simplest once they're set up. Okay, if they're already set up for you, the word problems, you just have to be able to understand what they're saying and set them up. But overall, it's not too bad. Any questions? Nope, we're good. Okay.